Alright, so one more example here. One thing I want to point out in the last example is that in the reduced row echelon form with these larger matrices, the 3x4s, notice that the reduced row echelon form still has ones going down to the right on this diagonal and zeros elsewhere. In fact, if you get really big systems, you can make systems that are like 16 equations with 16 variables, right? You could just keep going and going. You won't see that in this course, but you might see some that are 4 equations though with 4 variables. And so the reduced form will always have ones on this diagonal and zeros everywhere else. And the reason for that is that each of the ones represents a variable. Like this first one is 1x equals that number. This one 1y equals that number, and 1z equals that number. So you get your x, y, and z values. Okay. Now there are some other weird results, some other weird simplified matrices that happen in certain situations. I'm going to show you one of those examples and explain the rest here in just a moment. So let's look at this next example. This one is an example we also saw in the last section. I'm just going to utilize it again because I like it for what I'm going to do here. So again, I'm going to run through this with the calculator matrix. I'm going to write out the initial matrix: 2, -3, -1, and 0, 3, 2, 2, 2, and 1, 5, 3, 2. Now hopefully when I put this in the calculator I won't make another typo mistake like I did on the last one. We'll see. Alright, so let's get rid of that. So to put this in the calculator, you're going to go to Matrix menu. You're going to go over to Edit. Matrix A. It is a 3x4, so we're safe there. Now the numbers we're going to enter are 2, -3, -1, 0. Second row is 3, 2, 2, 2. Last row is 1, 5, 3, 2. Okay, so I changed all of my numbers, just typed over all the old ones. And then we're going to quit, go back to the home screen once it's entered. Then I need to do some math on this matrix, so I go second matrix, over to the math menu, down to RREF. I need to tell the calculator what matrix to use. We're going to use matrix A under names. Close the parenthesis, and I get this weird thing. Again, I've got some ugly decimals over on the side, so let me clean that up. I'm going to go to math, fraction. It's always nice. I like having the fractions in there, honestly. It looks a lot cleaner. So let's put that down here. Now my work, remember, as I'm writing this on a test, is going to be to write out this matrix. It's going to be 1, 0, and now I've got a weird situation here. I've got 4/13 and then 6/13. Then I've got 0, 1, that's a 0, then 7/13 and 4/13, and then I've got 0, 0, 0, and 0. This does not look like the reduced row echelon form that we've seen before. Okay, and the reason for that is you don't have ones on the diagonal. You're missing a 1 here. And you don't have zeros everywhere else. You've got a couple things that aren't zeros. Okay, so this actually creates a problem. When this occurs in the reduced row echelon form, you need to look at the bottom row. This bottom row tells me that if you rewrite it as an equation, 0x plus 0y plus 0z equals 0, right? That's what 0x, 0y, 0z equals 0. That's what all those mean. Of course, on the left side, all these zeros just make 0, and we're left with the equation 0 equals 0. Now, when the variables all drop out and you're left with a true equation, perhaps you'll remember from the last section that those result in systems with an infinite number of solutions. In other words, the three equations here that represent three different planes in 3 dimensions, like sheets of paper kind of, they would intersect either in a line or in another plane. Okay, so they have infinitely many intersections. Now, we categorize those. If they have infinite solutions, this is what we called a consistent system. Okay, so those were consistent systems. That's what we were looking at before. And because each of these lines is different from the other, no two of these are the same, I would consider these also independent equations. Okay, so consistent system with independent equations. Okay, so again, it's because of this entire row of zeros on the bottom. Now, there are some times where you will get a matrix, a reduced row echelon form, where the bottom row, let's chop this off, new example, where you do the reduced form and the bottom row ends up having a bunch of zeros and then another number, like let's say 5. Okay, and of course, you know, maybe a 1 here and a 0 and a 0 and a 1 and then some other stuff in these other places. And so if you look at the bottom row again, you would have 0x plus 0y plus 0z equals that number. The left side all zeros out. And what you end up with is a false equation. 2 numbers that are not the same with no variables left. In a false equation, we talked about this last time, false equation, you have no solution. So that's where these 3 planes do not intersect at a single point. Those would be inconsistent systems. Yeah, inconsistent systems. Okay. All right, very good. Moving on to the next section in the next video.